Hi everyone, today we're going to start 2.5, which is reason using properties from algebra. This is going to be our start for proofs. Here's some key concepts. The addition property. If A is equal to B, then then A plus C is equal to B plus C. Subtraction property. If A is equal to B, then A minus C is going to equal B minus C. Multiplication property. If A is equal to B, then AC is equal to BC. Division property. If A is equal to B, then C is not equal to 0, then A divided by C is going to be the same as B divided by C. And finally, substitution property. If A is equal to B, then A can be substituted for B in any equation or expression. So let's put all that together. So example 1. Write reasons for each step. We want to solve 2x plus 5 is equal to 20 minus 3x. Write a reason for each step. So the first thing I want to write is what is given. So 2x plus 5 is equal to 20 minus 3x. This is given. All right, so next I want to, let's move our 3x over. So I'm going to add 3x, add 3x. So then when I simplify this, I end up having 5x plus 5 is equal to 20. All right, well, what was my reason? That was the addition property. I'm just going to put add property. I added 3x for each side, so that's why it's the addition property. Next, if I were to try to solve for x, I would subtract 5 from each side. So 5x is equal to 15. So what property would that be? Well, subtraction. I'm subtracting. So I'm just going to put subtract property. And finally, to get x by itself, I would divide by 5. And so x would equal 3. So since I divided by 5 on each side, my reason was division. So the division property. And that's how we use equations and find reasons from algebra to prove what x is equal to. Let's do the same thing. So solve the equation for y. Write the reason for each step. So here's my two-column table. So in this first column, I'm going to write equation. And in the second column, I'm going to write reason. So the first thing I want to do is write out what is given to me. So negative 3x plus y is equal to 8. That is given. All right, so it said I want to solve for y. I have two variables here, but that's okay. So I just want to try to get y by itself. So my first step then would be to add 3x to each side. And when I do that, I end up getting, these cancel out, and getting y is equal to 3x plus 8. And that was the addition property. And I'm done. I have y by itself. There's nothing in front of it. So I am done with my algebra proof. Solve the equation for y. Rewrite the reason for each step. So I'm going to do a similar problem here. So I'm going to write equation, reason. All right, so what is given? Well, 4x plus 2y is equal to 12. That is given. All right, so if I want to get y by itself, what would I do? Well, the first step is to subtract 4x. Subtract 4x. That cancels. So 2y is equal to negative 4x plus 12. And what's the reason? That was subtraction. So subtraction property. Now, y is almost by itself, but we have that 2 in front. So to get rid of a multiplication of 2, I'm going to divide by 2, which means I'm going to divide 4x by 2 as well as 12 by 2. So then when I simplify, I get y is equal to negative 2x plus 6, and that was the division property. Distributive property. If A times the quantity B plus C is going to equal AB plus AC, where A, B, and C are all real numbers. So all this is saying is that you can take A and multiply it by everything inside the parentheses, and that's how you get AB plus AC. Solve negative 4 times the quantity 11x plus 2 is equal to 80. Write a reason for each step. All right, so I'm going to write equation and reason. First thing we always do is write out what's given. So negative 4 times 11x plus 2 is equal to 80. The reason, well, it was given to us. All right, so my first step here is I'm going to distribute this negative 4 inside the parenthesis, which gives me negative 44x minus 8 is equal to 80. So what property was that? That was the distributive property. All right. So I want to get x by itself. So my next step then would be to add 8. So negative 44x is equal to 88, and that is the addition property. And lastly, I need to get rid of this negative 44 in front of the x, so I'm going to divide by negative 44. Divide by negative 44. And when I do that, x is equal to negative 2, and the reason that was the division property. Key concepts. Reflexive property. So remember, the reflexive property is just saying that something is equal to itself. So for example, A is equal to A. AB is equal to AB. The measure of angle A is equal to the measure of angle A. Symmetric property. Symmetric property is just taking a statement and flipping it. So kind of think of a mirror image. So if A is equal to B, and I'll underline this, if A is equal to B, then B is equal to A. I can just flip that around and both those sentences are true. If AB is equal to CD, then CD is equal to AB. If the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. And lastly, the transitive property, which is very similar to the law of Sill. If we have the letters A, B, and C, if A is equal to B and B is equal to C, then we know that A is equal to C. Same thing for segment lengths. If AB is equal to CD and CD is equal to EF, then AB is equal to EF. And finally, it's kind of hard to say, let me move this. If the measure of angle A is equal to the measure of angle B, the measure of angle B is equal to the measure of angle C. Therefore, we can say that the measure of angle A is also equal to the measure of angle C. All right, so let's put all of this together now. So you are designing a logo to sell daffodils. Use the information given. Determine whether the measure of angle EBA is equal to the measure of angle DBC. All right, so the first thing I want to do is to write what's given. Now, looking at the information, there's nothing given, what I just read. But if I look at my diagram, I notice that these two angles have a red tick mark. What does that red tick mark mean? it means that they're the same measure. So that's actually a given. We know that the measure of angle 1 is the same measure, so equal to the measure of angle 3. Why? Well, it's given. All right, so I'm going to erase what I just wrote. So our goal here is that I want to prove that the measure of EBA, which is EBA, is the same as the measure of DCB. So DBC. So I want to prove that that purple angle is the same as the red angle. Well, if we look at the purple angle, we see that the purple angle is made up of angle 2 and angle 3. So I'm going to write that out, that the measure of the purple angle, which is actually EBA, is equal to the measure of angle 2 plus the measure of angle 3. And I know that because that's angle addition postulate. Adding two small angles up equals the larger angle. So angle addition postulate. Okay. I also can look at EBA and say, well, if angle 1 is equal to angle 3, then can't I use substitution and change this this 3 right here, and change that 3 into a 1 because of this statement right here. So let's rewrite this. The measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1. So I'll say that again. If we look at step 2, measure of angle 2 plus the measure of angle 3, well, from our first statement, I know that the measure of angle 1 is equal to the measure of angle 3. So I can use substitution and switch the measure of angle 3 to really be the measure of angle 1. So the reason was substitution. All right. Now let's look at the red angle. The red angle, CBD, so let's write that out. The measure of angle DBC is equal to the measure of angle 2 and the measure of angle 1. So I have the measure of angle 2 plus the measure of angle 1. And that was also the angle addition postulate, adding two small angles equal the larger angle. And now let's look at steps 3 and 4. I have written the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1. And I also have written down that the measure of angle DBC is equal to the measure of angle 2 plus the measure of angle 1. Those are the same thing. So therefore, I just proved that the measure of angle EBA is equal to the measure of angle DBC by substitution. And I'm done. All right, so here's going to be our last example. So in the diagram, BC is equal to CD. Show that AC is equal to BD. All right, so if I look, AC is this blue segment, and I see BD, it also shows you another length, which is the blue segment. What do they tell us? Well, the first thing they tell us is that AB is equal to CD. I need to write that down first. So AB is equal to CD. That was given. All right. Now let's focus on CAC. What two segments make up segment AC? Well, AC is equal to AB plus BC. So I'm going to highlight this. So AB is equal or plus BC gives me the entire segment AC. And that's the segment addition postulate. Next, let's look at BD. What two smaller segments are made up of segment BD? Well, it would be BC, which I'm going to highlight, and CD. You add those together, you then have segment BD. So let's write that down. So BD is equal to segment BC plus CD. And what's the reason? Once again, it's the segment addition postulate. But let's go back to our original statement. AB is equal to CD. AB is equal to CD. And let's look at 2 and 3, steps 2 and 3. They also have BC in them. So I'm going to write these two equations equal to each other. AB plus BC is equal to CD plus BC. So the reason I can do that, right, is I'm just using substitution. I shouldn't say substitution. I'm just taking those two equations, the AB plus BC, BC plus CD, putting them together by the addition property. All right. And I see then that I have the same statement because once again, AB and CD from this first step, I know that those are the same. Obviously, BC and BC are the same. So therefore, I just proved that AC, which is made up of AB plus BC, is equal to BD, which is equal to the CD plus BC. And why? Substitution property.